Hi, I'm Chris, and welcome to the Tidewater Forge. Hey there, welcome to the Tidewater Forge. My name is Chris. I'm going to talk today a little bit about how to make a forge, how to line one, how to insulate it, and what kind of burners to choose. Today, we're renovating. My old friend here who's been with me for about 10 years, and we tore out all the old insulation. Tore out the old burner, which was just a single steel pipe going in. It's using forced air and propane. In this case, house gas, because it's a lot cheaper and easier for me. And we're going to replace it with a ribbon burner. Now, ribbon burners are something that's been talked about a little bit recently. They're very popular with glass blowers. They're large brick kilns. They'll replace every second or third brick with one of these ribbon burners, which is nothing more than a brick with holes in it which connect to a manifold behind it through which forced air and fuel is fed. It gives a very nice soft diffuse flame. It heats the space a little bit more evenly, and it's more efficient. So we're going to go ahead and upgrade since we're replacing the beast anyway. Some of the material I took out of this is pretty nasty, old and crusty. You can see here, this is what used to be the floor of my forge. It's got a decade's worth of old flux and just nasty stuff. You can see where it's sort of eaten through here into the cable and through whatever used to be the solid bottom of it. So we're going to put in some new cable. We're going to insulate it with 2 inches thick, and then we're going to line that with Mizzou high temperature castable refractory, and that's going to give us a forge that should go on for another good decade. So hang around, we'll show you all the tips and tricks. So the first thing we'll talk about here is the actual ribbon burner itself. It starts with a box. We just made this up out of plywood, glued it together, and then in the bottom, which has a thicker section, you can see all these little holes drilled. These holes hold crayons. So that's about the size of the holes that we want our fuel air mixture going through, and the crayons melt out really easy, so it's a good thing to use. And you can drill whatever pattern you like in there. I actually have it drilled up so I can choose a couple of different patterns of burner. If I want something with more capacity or a little less capacity, I can have that choice. So what I've done here is, it's a little hard to see because I had to fix it. And in blacksmithing, everything is fixing something, it seems like. But on this brick that I've made is also a manifold. So a manifold, what I've got is a piece of steel, and it sort of has 2 lips on the bottom sides, straight walls, straight back, and then I welded sides onto it. And there's space between the molded material and the steel here so that the air and fuel has a place to go and distribute. And then this is the hole pattern that I've got. The reason this looks ugly as sin is because the casting that I used here was a little bit cool. I did it when it was really cold this winter. It didn't quite set properly, and it was starting to crack, and so I went back with some Mizzou and I just slathered it all over this thing to protect it, hold it together, and keep it solid. So that's why it looks like a mess. But I have 10 holes, and they're coming at a little bit of an angle, so I get a nice spread out flame. And what this is going to do is it's going to go inside the forge, and this pipe's going to come out a side hole here. We'll weld that in place, and then we'll put in our wool insulation. And that's how it goes. So the first thing we have to do is weld the burner in place. Got the trusty old stick welder here, so don't look at this. protection, face shields, gloves. Hand tools can hurt, but power tools, they maim. If you want to do this long, take care of yourself. We've got this all cleaned up now. Time to line. So what we're going to line the forge with today is a product called kale wool. Sometimes you hear it called Innswool. It's made from spun kale and clay. It feels a lot like fiberglass, but it's not a glass product. It's actually a clay product, an earth product, but it's woven into this blanket-like form here. You can see how it's sort of layered up. It's kind of fluffy, looks like cotton candy. This one happens to be a little bit waterlogged because it's been sitting outside, so that's not a problem. The forge will dry it out fairly quickly when we start curing things. But what I'm going to do is I'm going to take this and I'm simply going to wrap it up around inside this shell. And the shell is just nothing but an old propane tank. When it was empty and I decided I wanted to convert it, I just left the valve open, let it breathe for a couple days, drilled a little hole, let it breathe for another couple of days, so there was nothing explosive to worry about. Cut my front hole, cut my back hole, took off the various fittings, welded up this little place because I could put bricks on the front of it, which is nice. It helps contain the heat. Same thing on the back. And in the original version, just had that straight pipe coming in, which is great. I got up to wonderful heats. But I want to try this new burner out and see if it gives me a little bit better performance over time. If it doesn't, I'll just chop the brick off and run with the pipe again, because I know that works. But this needs to be replaced, so we're going to stuff it on in there. Now this reminds me of Thanksgiving. You wear gloves, you're shoving things into a small cavity, you know, lots of fun. So you can see, shoved it all in, pulled it all out. That's my first lining. I've got another piece I'm going to do a second layer with. That's going to make it look kind of tight. I'm going to compress it a little bit by hand. The reason we use this stuff is because nothing insulates like nothing. And the kale and clay has a whole bunch of air voids in it. And those air pockets are what helps insulate this. You'll have some people use old foundry furnaces, which are solid castable refractory. And that's fine. It'll work. The problem is it takes a lot of time and a lot of fuel and a lot of heat to heat up that material to the point where it's actually putting heat back into the system instead of robbing it. This does that a lot faster. So yeah, it's a little bit more expensive. It's a little intimidating to work with if you've never used it before, but it's a far better performer for what we're trying to do. And when I turn on my forge, when this is all cured and dried and done, from lighting it to ready to start making knives or tools or whatever else I want, hey, we're talking maybe 5 minutes. And that's worth it to me. So it's a huge efficiency. So here's what the inside looks like. You've got your ribbon burner brick on the right. We've got our kale and wool packed all around. Used little trimmings, bits and pieces to pack in the cracks. There's nothing important about keeping it all in one bit. You can see the bottom. I've got a couple of strips just to kind of level it out and raise the floor just a bit. And then when we coat this with refractory cement, you'll see it all come together here. That upper left, I'm going to have to push that wool up a bit. But what's going to happen is, let me pull back, the gas will come out here and it's going to swirl around. And that swirling action is part of what really helps in knife making and any efficient forging, actually. If you just have a point heat source, you tend to get a hot spot. So this might be a hot spot, but it's a 6-inch wide one, and by moving all around our work environment, it should heat our forge pretty evenly and be a very effective tool here in about another hour. So I'm going to go ahead and mix up some cement and we'll start laying that in. So this is what Mizzou looks like when it comes shipped. It's sort of like a concrete powder, a bunch of fine stuff. I get mine from Rick Furr. He's up in Door County, Wisconsin, and very popular, famous bladesmith. Secrets of the Viking Sword. Thank you, Rick. He bought a whole bunch of this stuff, so he's selling it to us at a very affordable cost. Probably less than it would have cost us to get it from the original manufacturer. So that's a great service. We'll try and help each other out. So we're going to take about 5 pounds of this, and we're going to mix it with just enough water to slake it and get it workable, and then get it in the forge. Now, just like regular old Portland cement, this stuff does cure with water alone. It's not a heat-curing cement. Now, there's some other products like Satinite and ITC 100 and some other things that you can get them wet, they'll dry, and if you need to crush it down and reuse it again, you can do that just easy enough. This, though, is going to set up absolutely solid when we're done with it. So we've got a bit of work time. It's not something that'll happen in just a couple of minutes. We'll probably sit here for close to an hour before it starts even thinking about getting hard to work. Probably more. Rick will leave a comment in the comments section. Educate all of us. You see how this is pretty stiff? That's what I want, because I don't want this stuff running off the ceiling of the forge or down the walls or just pooling up in a big puddle at the bottom. Just enough water to get it workable, but not so much that it's a mess. That's where these gloves come in really handy too, because you can do all this with just your hands and not worry about the cleanup afterwards. It's very convenient. Okay, so that's about ready. Alright, so now I just start taking handfuls of this stuff and slowly lay it in. I want a nice flat floor when I'm done, so I can sort of start there. I want to fill in these lips up front so that the gas isn't attacking the metal directly as much as possible. And nothing about this is an absolute perfect science. This is all trial and error. Everyone's a custom. Everything's an experiment. That's what I tell my students. That's what I tell my friends. And in my experience doing this for almost 20 years, it holds up pretty true most of the time. I'm sure somebody could watch this and decide they wanted to get into making old propane can forges and selling them on eBay or something, but I figure it's best just to do this stuff yourself, because then you learn what's involved, you learn the important principles of it, and once you have knowledge, that's not something you have to keep buying. So consider this my favor to everybody looking out there for a way to get things done. This is the first step. You got to have a forge. This is a pretty good one when it's done. So I could apologize for not showing you the rest of this, but it literally looks like a kid playing with mud. And there really isn't much to show. So the trick is just get everything evenly spread about as best you can. Front, back, left, right, top, bottom. Again, we just want to encourage that gas to sort of swirl around. So you see on the upper left there's a little bit more curve, whereas the right face is a bit more flat. Of course, the floor is pretty flat now too. I did have to cheat and do the cooking show thing, so I mixed up a little bit extra cement just to help fill in the floor a bit, and I mixed it a little wetter. As you can see, it's sort of pooling there, and that's to give me a nice flat floor. I'm going to let this sit for about 10 minutes and just kind of get happy and do its thing. Then I'm going to pull out my best friend, the Harbor Freight Weed Burner. So the wind's picking up. I've got a fan on because you want ventilation when you're burning things, but this is probably the best $15 I've ever spent. Little flamethrower. We just want to get some of that moisture out of there, because otherwise the burner's not going to run right. I've built one of these before, and we tried lighting it when the whole thing was wet, and it took forever to get a stable burn, because just anytime you had any flame, you just kicked off so much steam that it put the fire right out. So I'm just going to use this burner through the big open front to try and get some of the moisture out, get this ready to test up here in a minute. Alright, you can see with just this little bit of flame here, if I aim it at the top, you'll see how the flame swirls around, kind of goes in a big spiral motion. Well, that's what's going to happen when our main burner is running, but with a whole lot more energy. I've only been doing this for just a couple of minutes now. You can see the bottom is still kind of muddy. You can see some of the little specks starting to dry out. When I take away the flame, just look how much steam this produces. So we've got a whole lot of water in there that we need to drive off, and we're going to do that nice and slow so we don't blow anything up or overstress the system or get a whole bunch of cracks. We're just going to take our time and slowly cure this out and drive off a bunch of that water. We'll check back in when we're done with that. Alright, so we've cooked out the forge a bit. It's still steaming, as you can see, and it's going to do that for a little while, so we're just going to let that cool off, do its thing, get rid of some moisture. I'll fire up the burner in a minute. What I want to talk about for just one moment is the plumbing that goes into the forge in the first place. So, like I said, this is a blown air propane forge. That means I've got an air blower. Mine happens to be a recycled salvaged unit from an old Moon Mountains toy, which is probably a lot bigger than you need, but it gives me plenty of air, plenty of pressure. Works just fine. Has about a 4-inch outlet, so 4-inch flexible dryer hose of the rigid stuff works really well. And I have a reducer that's made out of a tomato can. This is all very shade tree stuff. And that hooks onto here. So what this is this is my main burner assembly. So I've got air coming in here at a pretty high rate of speed and good pressure. I have this ball valve, which lets me control how much air goes down the pipe that way. This is a quick release fitting for my gas. Now I've got this particular fitting on, and this fits both the house gas line here as well as a regulated line if I'm going to run off of a tank. So if I want to go out and demonstrate somewhere, I just need an extension cord for the blower, and then I can run off a propane tank. It's got the same fitting, hooks right in here, so I don't have to be messing with wrenches and seals and anything. This is all sealed up. It's good to go. And then this will screw into the pipe that goes into the forge. So what will happen is we've got air coming in, we mix fuel with that air, and that fuel-air mix doesn't burn back up the pipe. You don't need to worry about exploding yourself, because as fuel burns and it expands at about a 10-to-1 ratio. I'm sure someone will correct me on the exact science of this, but the point is it has to get bigger in order to combust, and it can't get any bigger in this fixed diameter pipe. So it only happens where it comes out the burners. And that's a good thing for us, because that means we don't blow ourselves up. Safety first, or third, maybe. Depends who you talk to. But it's as simple as this. A handful of plumbing parts. It might cost you 10, 15 bucks down at the hardware store. These fittings are a little bit pricier, but I find them worth the expense because it just makes everything a whole lot easier. The size is 1 inch, and for anything that isn't going to be terribly hot, Galvanized is okay. You don't want to burn galvanized steel because what that's going to do is create zinc vapors. Zinc vapors have the potential to lead to things like metal fume fever, and that's not something you want to deal with. And there are all kinds of industrial warnings about that out there in the literature. As for the cable we put in there, it's relatively harmless. I've heard people talking about the MSDS sheets for it. It's just spun kaolin clay, but that in itself is a silica product, and loose silica fibers, you get those in your lungs, you might end up with something called silicosis, which is really bad, and you don't want to have to deal with that long term. So a second reason for insulating all this with the castable refractory is to kind of seal away the kaolin clay. We want a nice firm barrier between us and it keeps loose fibers from detaching and floating out and getting into our airspace. There's probably a few. Again, this is all very shade tree. It's probably not ISO 9000 certified, but as far as we're concerned, it gets the job done. I've been working for 10 years, and I don't know anybody personally who's run a setup like this who's ever had any health issues, if that's on your mind. Anyway, let's finish curing it out, hook up the blower, and see if the thing works. And so this is what the apparatus looks like when it's all connected. So I've got the base that sits on my steel table over here, so I've got room for my reducer to hook into that. I control my air, my gas comes in from the side, it's got a ball valve on it, and then everything goes into the forge. It's nice, it's balanced, it's easy, it's common plumbing parts, pretty cheap to put together, and I think it's dinner time. So I'm going to go get some food, let this dry out some more, we'll come back, fire it up.